So yes, today I'm going to talk about the quantification of skeletal traits and gait characteristics in commercial turkey toms. So for starters, commercial turkey toms, similar to the broilers on the line, or excuse me, the broiler lines on the market, are bred for high body weights and short amount of times. As you can see here, these graphs were adopted from some performance objectives that were released by a couple different lines, and it just gives a representation of that exponential body weight growth that is happening throughout their production period. And as you can see, they reach over 25 kilograms by 22 weeks of age. I also included their average daily gain just to get an idea of how much that is increasing throughout. While that rate does start to slow around 12 weeks, this is just another way of seeing how much these birds are truly growing in a shorter amount of time. And while this is an economically necessary trait, it can pose different issues to the bird. What we will focus on today is lameness, which can be caused by both this genetic predisposition and some other factors. So a little bit about lameness. It is observed in less than 3% flocks in less than 3% of flocks in the US. While this might not seem like a lot, one of the big issues is also that lameness symptoms and more severe cases tend to happen in the later ages of production, and this is after the birds have had a lot of time, care, and money put into them. As mentioned, genetic selection can be a cause, but there's also different pathogenic cases. There's developmental abnormalities, their environment can influence, and then same thing for their nutrition. And while this, as I mentioned, is an economic issue, it's also a large welfare concern with these birds. So a few examples. This image shows a case of foot pad dermatitis, where you can see this lesion here. So foot pad dermatitis is most often caused by subjection to poor litter quality. When the litter gets really wet and cakey and the birds walk along it, they start to have these lesions form, and not only do they become painful to walk on, but can become a breeding ground for secondary infections. And on the note of infection, this is the turkey arthritis reovirus, which is an example of a pathogenic cause of lameness. This has a lot to do with enlarged tendons in the hock area, and they can also lead to rupturing and hemorrhaging. And then one of the most common developmental abnormalities would be tibial dyschondroplasia. And this is when there is unmineralized cartilage left in the proximal end of the bone. And while this happens early in the bird's life, the symptoms are not typically observed until later on in at least 10 to 12 weeks of age. So one of the methods to kind of combat or prevent lameness is gait scoring. So gait scoring has been around for a while, and it is the concept of quantifying a bird's walking ability or identifying impairments. The two main ways are subjective, and this is what is most often used. It's when you use a categorical scale to identify where the bird falls in terms of having impairments or not. The most common scale is the Bristol scale, which goes 0 to 5, and with a 0 being a normal bird and a 5 indicating severe lameness. While subjective is very efficient and effective on a commercial setting, it does pose the risk of human error and bias. And with that, people have started to investigate objective methods. These are usually more on the technological side of things, such as camera analysis or accelerometers, but they conduct lameness analysis by taking in gait parameters and quantifying them. Now, gait scoring is obviously necessary for economic purposes, welfare, and they can also be performed at the breeding level to assist with proper genetic selection. And here is just a demonstration of a subjective gait scoring to kind of give an idea of, you typically have two observers and how they would look at the birds, and then C and D depict valgus and varus to show some developmental abnormalities. And so then just a brief overview of how we looked in all this. So we had two main replicates that we performed, and they will be referenced to as E1 and E2. Each focused primarily on the use of environmental enrichments to look at their impact on skeletal quality, as well as age effects. However, in E2, we did do a sub-project looking at quantifying gait parameters using a pressure-sensitive walkway. So for both E1 and E2 at week 1, 400 male turkey poults were placed at Purdue University. At week 5, they were provided their environmental enrichments, and I'll go through those briefly. We had our control pen, a platform accessed by 2 ramps, a pecking block suspended in the pen, a straw bale, a tunnel enclosure, and then we also had a group which had forced locomotion through the use of a robot. And so this robot just had brighter lights, and then obviously you could kind of hear the sound. And every other day it was moved around the pen for 20 minutes to help just encourage the birds to stand up and start moving around. So 8 weeks was our first sampling point for each replicate. E1 focused on the load-bearing bones, so we sampled our right tibia and femur. E2 focused on load and on-load bearing, so we sampled our right tibia and humerus, as well as plasma for later bone biomarker analysis. Week 12 was our second sampling point for E1. Week 16 is when we did our pressure-sensitive walkway analysis, in which we collected 2 birds from each pen, giving us 48 total birds. And each bird was gait scored either 0 or 1, to where we had 24 of each score. And they were then subjected to the strideway analysis, which I'll go over in a couple of slides. And these same birds, their right tibia and humerus were taken. Week 17, we took the remaining samples from E2, and then week 18 was the remaining samples during our first replicate. So in terms of quantifying our bone properties, so we measured different morphological parameters such as the weight, the length, their anterior, posterior, and medial lateral diameters, and then those were averaged together. And then we also performed a 3-point bend test to quantify our biomechanical properties. Specifically, we looked at peak force to fracture and the energy required to fracture. And this is an example of a 3-point bend test. And as you can see, the bone is supported on either end, and then the load is instilled at the midpoint. And so once that bone begins to fracture, the machine starts to send the information over to the computer, and it will yield us a stress strain curve. And that is what we can use to identify these different biomechanical properties. Now for our gait parameters, as I mentioned, we used a pressure sensitive walkway in which the birds made 4 passes. Each image was then gone through manually, and any that could not be, were not deemed analyzable were removed. And it's important to note that the birds were habituated prior to their the use of the pressure sensitive walkway, and they were weighed. Now here is an example of a bird being coaxed along the pathway. As you can see, there's a fence up just to make sure that they stay walking completely on the pathway and don't wander off. And so that bird, this is their computer recording also. So this is what the pressure sensitive walkway collected as the bird was moving across. You can see there's different color pixels indicating different amounts of pressure, and you can tell right versus left paw print for analysis. So some stats for our focus on the age and treatment effects. We ran ANOVA for our body weight and the various bone parameters. After running this, I will go into some of the Pearson's correlation coefficient that we decided to perform to look at body weight correlation with skeletal traits. And then for our quantitative gait parameters and the bones sampled from those birds, ANOVA was used for those comparisons. Our significance was declared at p less than or equal to 0.05, and then trends were also acknowledged at p greater than 0.05, but less than 0.1. And JMP was used for all analyses. So the first objective, taking a look at the age and environmental enrichment effects on the bone traits. So we'll go briefly over some treatment effects. A few that I'll highlight are at 8 weeks of age, the tunnel enrichment had an effect over the platform enrichment in our femur and our femur and humerus for our diameter and bone weight. We did see a biomechanical difference at 8 weeks of age with our tibia, with the pecking block group being higher than our control and straw bale. And then transitioning into our body weight effects. So here just highlights how much growth is happening between these main age points, the 8, 12, and 18 weeks. And we can see that there is a vast amount of growth happening in both sets. There is more growth from 8 to 12 weeks compared to 12 to 18, but it is still growing substantially. And so for the sake of time, I'm just talking about tibia today. And here and for the remaining graphs, age will be on the x-axis and our parameter is on the y-axis. And so here we can see our bone length, diameter, weight, and then peak force. And similar to our body weight, more growth is happening from the 8 to 12 weeks of age compared to 12 to 18, while all are significant. And once we observe this difference, especially bone weight, as you can see here is a drastic difference, we decided to look at Pearson's correlation to see if there was any relation between body weight and different bone parameters. So sticking within our tibia, I decided to focus on the biomechanical feature of peak force with body weight. So here, 8 weeks of age, we see a moderate correlation between peak force and body weight, but as the birds age, it drops to a 30% correlation, and then we actually have a negative correlation by the time the birds reach 18 weeks of age. So from this, we were able to conclude that a heavier bird does not mean stronger bones, and then on the other hand, a lighter bird does not necessarily mean weaker bones. And after considering this, we decided to take one more look at peak or at the bone traits relating to body weight by doing an analysis with our body weights broken up into groups. So here you can see we had a low, medium, and high body weight group, and at each age point, they were analyzed again. 8 weeks, we did not see a significant difference, but at 12 weeks, there was a difference with the body weight group being having a stronger bone compared to our medium body weight group. But then the key point is that by the time the birds reach 18 weeks of age, that difference is completely gone, similar to what we saw with our correlation. So quick summary there, our treatment effects were limited and at a younger age and then overall inconsistent. A lot of the bone growth does appear to be occurring at the earlier ages in the bird's life. And then our correlations did decline pretty drastically as the birds aged. And another figure to kind of go alongside this from a paper, this red line indicates the later half of a production period in some toms. And then the blue line is the earlier portion, while the green is from the 0 to 20 weeks. And as you can see, there's a much higher genetic variance in the latter half, similar to what we saw with our lack of correlation as the birds aged. And then just to briefly go over our comparisons between the subjective gait scores and the quantitative gait parameters we collected. So for the rest of the presentation, GS0 indicates a bird with no impairments, while GS1 is a bird with mild impairments. So these three parameters focus on the cadence, gait time, and gait velocity. And through these, we saw that birds' gait scored a 1 were taking less steps per minute, but taking a longer time and doing so at a lower speed compared to the birds that were deemed to be normal or have no impairments. We then looked at not only the comparison between gait scores, but also took a look at the limbs. So the way this analysis was conducted, for example, the right limb of a bird gait scored a 0 was compared to the right limb of a bird gait scored a 1. So when looking at these, our step length and our step time, we see here that birds gait scored a 1. They were taking a longer time to take a longer step with their left limb compared to birds gait scored a 0. But when considering our stride length, the birds gait scored a 0 had a longer stride in their right limb compared to our birds gait scored a 1. And then we took a look at a couple other parameters that I'll show here. So max force and peak pressure are indicative of how much weight is being placed on the limb. And so kind of similar to our step data that we saw, our left limb of our bird's gait scored a 1 had a higher peak pressure and max force compared to the left limb of bird's gait scored a 0. However, our single support time, which some have observed to be an indicator of how much weight a subject may be willing to bear, we saw a higher right minus left difference in birds gait scored a 1 compared to 0, which shows that the birds gait scored a 1 were relying a bit more on their right limb compared to the birds with a 0. So to briefly summarize those, our gait score, while it was not shown, it did not have an influence on body weight. We did observe that cadence, gait velocity, gait time, they were confirmed to be different between our subjective gait scores. our left limb did appear to be different in the birds with impaired gait compared to those with unimpaired. And again, while it was not shown here for the sake of time, our gait score did not impact the traits of the tibia or humerus that were sampled. So overall, we did confirm and observe that commercial turkey toms are growing more quickly than their skeletal systems are. Our environmental enrichments, while had some effect, was relatively minimal, but could be further observed. One of the big things is that there does appear to be the potential for selection to switch gears a little bit towards skeletal health without sacrificing our current accomplishments with high body weights. And then our subjective gait scoring method that was performed was able to be supported via our objective parameters that we collected with our pressure sensitive walkway. And I don't know if I went too fast with that, but it's just some acknowledgements to the RegMe lab, all of their help with everything from cleaning bones to analyzing data, the Erasmus lab for their assistance with this trial, especially communicating all the details with me since I am a couple states away. Also the Brito lab for their assistance with the birds throughout the trial. And then a thank you to the USDA NIFA for the funding of this project. And I'll take any questions.
Well, thank you so much, Stephanie, for your excellent talk. We have a few questions for you. Did you look at how the birds also use the enrichments? Did you find that they sort of used them less over time, or was it kind of consistent throughout the study?
So I did not personally look at the behavior aspect. That is something that is being worked on in the Erasmus lab. What I can tell you that was very interesting to learn is, as you kind of saw when the birds were younger, that tunnel enrichment was having some positive effects. So my first assumption was, okay, maybe squatting is kind of, helping the bones there. But then after a conversation with Gideon, I learned the birds kept jumping on the tunnel and because they kept having to replace them. And so that's one of the ways we're like, okay, well, obviously jumping can do a lot for your bones. So it's exciting to see them using it in that manner. Same thing for straw bale. Not all of the effects were presented there, just to go over them briefly, but there were some positives with that. And I know Nathan told me E1 versus E2, one of them like did more jumping while the other replicate, it was more just pulling out the straw. But there is going to be more behavioral analysis so that we could also try to see like how often the birds that I have my samples and data for were using those respective enrichments to kind of do more of an individual analysis.
Great, thank you. Let's ask one more quick question before we move on to our next speaker. When you were looking at the gait, did you notice that like they had more issues in one leg versus the other? Because you mentioned that always like you could see differences in the gait patterns between them, but could you identify which leg specifically had the impairment?
Right. So I did do because the way the system produces the data is a little weird. So I did like some manual analysis to look for any asymmetry. I did not see any within the groups of birds. However, I had a lot of parameters where it looks like that left leg they might be relying more on. I can't say it with full confidence just because there's not necessarily the data backing it up. And we did unfortunately only collect the right tibia. In the future, the left one will help to kind of look also at like bone wise any asymmetry. But as far as just a general analysis, there did not appear to be any.
Great, well, thank you very much
Thank
for
you.
the amazing